Hello everyone, I am Sara and I am a master student in biomedical physics at Complutense University of Madrid, and this tool was developed as a part of my final research project.
Hello, I'm Irene Hernandez-Giron. I'm a medical imaging researcher at the Leiden University Medical Center, and together with Julia Garayoa and Margarita Chevalier, we supervise Sara.
We want to share with you an open code solution to create smart customizable vessels models for a 3D printed anthropomorphic phantom.
Image quality is usually assessed in radiology with simple geometric test objects containing patterns. There is not a direct way to translate these technical measurements to the diagnostic image quality required by the radiologists. Anthropomorphic phantom exist, but they lack in general of tissue texture and internal organs detail. Those who offer them are usually expensive and not widely available. The use of 3D printing in different applications in medicine is on the rise. There is a need for realistic anthropomorphic phantoms that mimic the X-ray attenuation of patient tissues and their anatomy and morphometry. 3D printing is being used at research level to manufacture customized texture anthropomorphic phantoms for image quality assessment. The evaluation of accuracy and reproducibility of 3D printing techniques for phantom creation is still under development, and this in partly motivated this work.
This work consists of generating customized models of small vessels trees that could represent to some extent lung or liver vessels. For this purpose, we present a simple open code based on Matlab. The user can select different parameters either via a graphical user interface or manually in the code itself within certain constraints. First of all, the number of generations. This is the number of levels or number of times the branches of the same level will be divided. In second place, the number of branches in a bifurcation. It is the number of daughter branches that are generated from the same mother branch or generator branch. Also, you can select the value of beta. This is the angle between the daughter branch and the mother branch. Next, height, inclination, and radius are initial parameters that are selected for the trunk. Thickness and length reduction factors are the factors that determine how the thickness and length of a daughter branch decreases in relation to its mother branch. As we can see in the first example, the factors are reduced and the branches are shorter and thinner. On the other hand, in the second example, by increasing the factors, the branches become longer and thicker. There are three possible view options of our final result. The preview consists of a quick way to see the final structure of the fractal tree using straight lines. The view is an option that allows you to observe the final structure of the fractal tree in 3D. In this option, you can choose what you want to visualize: straight lines, dotted circles, cylinders, and so on. Finally, the STL option allows you to display everything that has been previously displayed in the other options, and in addition, STereoLithography files are generated as output.
The output STLs can be further post-processed before printing. Here you can see an example with Mesh Mixer, which is a design freeware, where you can transform, check the dimensions, rescale, and export a final STL as input for your printer of choice. The software output can be manufactured into small phantoms with your printer and material of choice. Afterwards, you can check the printing process, measuring the phantom directly with a caliper or on the images, also for attenuation checks. You can combine several small vessel models by post-processing to create bigger and more complex phantoms too. The software as it is intended only for learning purposes and not for clinical use. This code can help medical physicists to learn at a small scale about mathematical generation of vessel-like anatomical structures and to get access to small and affordable test objects for medical imaging. You can also use it to evaluate different 3D printing materials and techniques. If you're interested in the code, you can find us here. Thank you for your time.